So, okay. Oh, yeah. Ouais. Quoi? C'est comme ça. Okay. Okay, I think we can start. Okay. So before I start my presentation, I would like to ask you a question. Do you know what does a car need to move? Okay, among other things, a car needs wheels to move. So what's a wheel? A wheel is a circular object that rotates around an axis. Wheels existed way before cars were created, and then humans used these same patterns of wheels to develop their cars. Nowadays, the cars are very developed, but what allowed us to have this kind of technology? It's because we never reinvented the wheels, we just developed it. And other than that, you know that in our lives, we live day-to-day repetitions, we do the same tasks every day, and even sometimes we face problems that other developers have faced. So this is true for a lot of stuff, and one of those things is data integration. So this is why today I'll be talking to you about integration patterns and how we use it with Mulesoft. So first, to introduce myself, so I'm Alain Goussoub, I'm a Mulesoft architect at Deloitte, based in France. I'm a Mulesoft mentor, delivery champion, and have 12 certifications between Salesforce and Mulesoft. So what is an integration pattern? An integration pattern is like an abstract pattern. So it resolves the most common problems that we have today, that any developer will meet in any project. It does standardize the method that we use to develop our project, and of course it can be optimized for different use cases. And where did this need come from? So as you know, integration is about connecting different systems to each other. So the need came when companies started using applications to save their data. And us, as developers, architects, consultants, it is our role to guide our clients to use these design patterns in order for them to gain more perception on them and have more efficiency, and so that the project can be successful. Okay, so before we deep dive into our agenda, I would like to remind you something very important. It's that you should always do a design before you start your development. This is very crucial, and this hashtag will be present in all of our slides because this is the message that I want to pass today. So for our agenda, as you know, there are multiple integration patterns, so a lot of them. So in order for you to be able to go back home today, we won't talk about all of them. We'll only talk about 6. And I chose these 6 because those are the ones that are most commonly used. So there's the migration, broadcast, bidirectional, correlation, aggregation, and reliability. So let's start. For the migration pattern, so like the name says it, it's to migrate data from one system to another. Let's say a company has just bought Salesforce and wants to move its data from an old system that's local to the cloud, to Salesforce. So this is what the migration pattern is all about. It's unidirectional, so only from system 1 to 2 and not the other way around. And for this migration, we can choose to have a full load or a delta load. So we can choose to move all the data or some part of it. Some part of it, like for example, I want to move only the customers that were modified the last year to my new system. And on top of that, we can do a change on this data. So the format, for example, if it's JSON on the source system and on the target system it's XML, we can do this change. And we can also add data to this to our information. And now the result of this migration pattern will be a report containing all the data that we moved, and if there are errors, so that we know what they are and we can replay them. And now the important part of our presentation is how we use this pattern with Mulesoft. So we only need 3 APIs. one process API that runs on a scheduler, so let's say every 30 minutes, it pulls the data from a system API that's connected to our legacy system, and we pull this data, do the transformation, and then we move it to our target system where we need the information to be stored. Very simple pattern. Now we move to the next one. It's the broadcast pattern. So it's for moving data from one system to multiple systems. So let's say, for example, I modify the customer on my customer web portal, and I want to move this information to target system like the CRM, inventory analytics, etc. So this is what this pattern is all about, moving the data from one system to multiple ones. And it's in real time and there's no delay. So how do we use it with Mulesoft? As you can see here, so we have one process application and 3 system applications. The system applications are linked to the target system, and the process application will be subscribed to a queue. So a queue and can be Kafka, any point time queue, anything like that. So when we do a modification on the customer web portal, on the source system, it will be transferred to the queue. Mulesoft will read this information, do a modification on the data based on the target system, and move it to the target systems. Now the good thing here is that there is no need for Mulesoft to check if there is a notification on the source system. We only pull the data, and here it's the source system that sends all the data to Mulesoft, so Mulesoft doesn't pull it again. So it's like a notification containing data also. Now for this broadcast, there are 2 other cases that we can discuss. The second case is when the source system only sends a notification, but without the data. So what happens here is that the source system sends the data to our queues, but this data contains only a primary key, so that Mulesoft can know which data to pull from the source system. And we have one more system API compared to our first case. So the process API calls the system API to pull the data based on the primary keys and sends it to the target system. So the advantage here is that it's a very lightweight notification. The source system doesn't have to send a lot of data. And that's it. Now for our final case in the broadcast, so is when Mulesoft controls everything. So the source system does not send data. Mulesoft only runs on a scheduler, pulls the data from the source system, it checks if we have any modification, and sends it to the target system. But the disadvantage here is that we can have more API calls on our source system, even though no data has been changed. So there'll be more API calls for nothing. Okay, that's it for the broadcast. Now we move to the bidirectional sync. So this pattern is mostly about 2 systems talking to each other. So for example, when the source system makes a call to the second system does what it needs to do and sends back the data to the source system. But here it will be an asynchronous, because maybe the target system needs time to do all this treatment. So it's like we have one big load of data, but this data is modified on both the target and source system at the same time. Now to do it with Mulesoft, it's very simple, but a little bit costly, because we will need 6 APIs to do it, just to make the calls between these 2 systems. So the first one is experience process and system from the source to the target, and the other one is from the target to the system, also with an experience process and system API. Okay, now for the correlation pattern. So it's like the bidirectional pattern, but we only do the synchronization when we need it. So let's say for example we have a bank that has different branches in multiple cities, and we have customer A. Customer A is in the first city, so his data will be in the branch X. So his data is there in the format of this branch. Let's say after 1 year, this same customer moved to another city where the branch Y is. So we need to move this customer from the data from branch X to branch Y. But here we have a risk, because branch Y might have a different way of storing the data. For example, the first name and last name in branch X can be in one field, but in the branch Y it can be put in 2 fields. So we might have false data or even redundancy. So this is what the correlation pattern fixes. So how do we use it? We use it with Mulesoft. Actually, we'll have a system API for each branch and one process API that does scheduling to check if there's any modification on any system and pulls the data and then sends it to the other systems. For example, here the process API takes everything from the system, from the branch X, takes the data, does the mapping, modifications, etc., and send it to the target systems. But here, the important thing is that everything and every branch should be documented very well, very clear, so that the process API does exactly what the target system needs. Because if there's an error, it can be a big issue. So this is why it's very important to design before you start the development. Yeah. Okay, the first integration pattern, we're almost there. So it's aggregation. Aggregation, like the name states it, it's to aggregate data. So if you have multiple source systems, you want to fuse the system and send it to the target system. So yeah, how do you do that with the Mulesoft? Okay, we'll have 3 system APIs. Each system API will be linked to a source system. So we want to pull the data from the ERP, inventory, and the CRM systems. The process API pulls this data, fuses it, and then the experience API takes this data. So what happens here is that if I want to take information from these 3 systems, I only call the experience API, and Mulesoft does everything, takes it, and I have everything, for example, a report. And finally, for the reliability pattern, so it's a pattern that should be, like the name says it, reliable. So as you know, we have 2 types of transport protocols. There is the transactional and the non-transactional. So the non-transactional is not safe because, for example, when I do an HTTP request and I have an error, I cannot replay what I did. I only have the error, okay. I can't do anything about it. So with the reliability pattern, it adds it has a transactional support to this non-transactional transport. So, for example, let's take this case where we don't have any security. We do an HTTP request. We put the data in the first database. There's an error in the second one. We can't do anything. That's it. So how do we implement that with Mulesoft? It's actually very simple. We'll have the 2 types, the transactional and non-transactional transports. So in the non-transactional, it's only HTTP request from any system to a queue. On this queue, we save our data, and then we have our Mulesoft that reads this data from the queue, sends it to the database. Now, if we have an error on the second database, for example, we can move what we did to a dead letter queue. A dead letter queue is a queue where there are the errors, and we can repull the data from there to replay it in case we need it. Okay, now, as for the benefits of the integration patterns with Mulesoft, so first we'll talk about the efficiency. So all our projects will move faster because we already have these integration patterns that are developed, and they will help all the teams do what they need to do. And then in terms of consistency, so we'll have the same system of data saved in everything everywhere in our project. So it will be easier to standardize what we do. If there is an error, we'll know where to check it. And also for maintenance, if you want to do an upgrade, it will be easier. And finally, for the key takeaways, so as you know, Mulesoft is very strong. It does seamless integration between applications. And integration patterns are here to provide us a way to standardize all of that. So if we fuse them, we can have something very powerful, and it will help our client accelerate their projects, have more efficiency and more scalability. Here are the references, and thank you. Any questions? It was clear? Okay. Okay, thank you.